There are no real solutions to that, because you can't have a real number squared plus 25 equal to 0. You just can't do it. The solutions are actually imaginary. So I only found one solution. Actually, we're missing something. And the reason we're missing something, well, let's see if we can understand why that is. What's the other way we can solve this? Factoring, right? So this is w times 1 minus w equal to 0. So factoring is a much safer way of solving things because it helps you not lose things. Almost. What does this tell us? W equals to what? W equal to 0 or 1 minus w equal to 0, right? Which means either w equals to 0 or w equals to 1, right? So 0, hey, 0 is the other solution that we missed in the black writing. Why did we miss 0? Does it make sense that we lost 0? Why did 0 get lost in the mix? What's the story of 0 here? What did we do? I divided by w. When does that make sense? So this is not legit for w equal to 0, right? So when you divide that equation by w, you're losing information about what happens when w equals to 0, and that's why we didn't get that one. But we did get w equal to 1. So dividing equations is very dangerous because if you're not careful, you'll forget that there's terms and conditions to dividing by variables. The term and condition is that it has to be non-zero. Let's see here. Now we'll do exercise 27. And then I just want to do rapid fire about 5 examples for you. So here's exercise 27. We have 7b cubed equals to 175b. So I think the first thing I'm going to do is divide by 7, right? What happens, 175 is 7 times 25, right? 7 quarters is $1.75. So if I divide by 7, I get b cubed equals to 25b, right? So now I'm going to try to factor. How do I factor here? Well, I need to put everything on the one side, right? So b cubed minus 25b equals to 0. How do we factor that? Take out the b. Let's see here, b squared minus 25 equal to 0. But that factors to b minus 5 times b plus 5, again using difference of squares. And so, as I was advertising, a cubic problem can have as many as 3 answers. This one tells me that either b is equal to 0, or b is equal to 5, or b is equal to minus 5. So we get 3 answers to that problem. Let me start this thing up here. So something I need you guys to pay special attention to. When we're solving equations, the number is opposite in sign of what appears in the factoring. So let me just write down some examples of that, just to try to drive this point in. If I have x plus 2 times x minus 3 equals to 0, right? That means that x plus 2 equals to 0, or x minus 3 is equal to 0, which tells me that either x is equal to minus 2 or x is equal to 3. Now, I would argue after you do this middle step about the 100th time, you don't need to do it anymore. You can just write down answers. In fact, that's kind of the point of factoring, is that we can just write down answers. So if I have like x plus 10 times x minus 13 equals to 0, or if I have x plus 5 squared equals to 0, can you guys tell me the solution to those with just looking at them? And or 13, right? We could write it as a list, and this one tells me what x is equal to. Nope. Just minus 5. And I usually write twice, like twice over here. So hang with me for just a second here. I got something to show you. So I will be posting this in course content as soon as class is over. All right. Can you hit the lights in the back for me? Whoa! Oh! Yeah. So my back said that I was still in the chair. So I made a little handout where I actually have written out the derivation of the quadratic formula. I don't expect you to be able to do that on the quiz, obviously. Just recording it for posterity. There's the derivation of the quadratic formula. The key point here is that completing the square is the key ingredient of that, right? And so on the next page, I give 1, 2, 3 examples of completing the square. I make a remark here that basically we've got 3 cases, right? The discriminant, I think I need to resize. The discriminant, I'll zoom in a bit, yeah. We got the discriminant positive. We have the discriminant 0, the discriminant negative. Those correspond respectively to distinct real factors or a repeated factor, right? Or a complex, irreducible prime case. And here's another example, completing the square. X squared, completing square, nothing to do. X squared plus 3. Again, completing the square is stupid here. Don't do it. I mean, it's already done. Example 7. Obviously, we could guess and check that is best, right? But you can also complete the square and derive x plus 1 times x plus 2 with completing the square. Example 8. If we have an odd factor, it's annoying. We have to do fractions. So like minus 81 over 4. And, as a shortcut, it's helpful to rewrite the constant coefficient as a fourth. Like 2 is 8/4. That makes this arithmetic go better. And then it even works for something like x squared plus 15x, completing the square. We'll still rederive the factoring the x out. And then last but not least here, page 4, I give a bunch of examples of every one of the things I just factored. I show how factoring will give you the solution. So here's a bunch more examples of factoring and solutions for you to look at. And also here's another way to solve them by taking plus or minus the square root. So obviously this example 6 is not part of this yet. So what I was telling, I think it was Kiana, left earlier, is page 5 you can essentially ignore for now if you want, but that will come back in chapter 7, okay? So anyway, I'll see you guys at the quiz when? Monday, right? So hope to see you there. Don't skip the quiz. Arrgh, you guys.
I can't believe you're actually making us come to class Monday. Yeah, I saw a message, and I read at the bottom that this means there's class on board.
I know, I'm sorry, but
I do that to us.
I mean, I could have stuck with the course schedule and had the quiz today. But I don't think I would have liked what happened if I'd done that. Excuse me.